S-plane poles, prove that all stable S-plane poles are mapped to stable Z-plane poles. Stable Z-plane poles in bilinear transformation. So that's the question. You have to prove that all stable S-plane poles. So first we have to want to know whether that idea is clear to you. Stable S-plane poles and stable Z-plane poles. So one important thing to keep in mind is that bilinear transformation is used to convert your analog transfer function into digital, right? So this is a mapping from S-plane to Z-plane. So this is a mapping from S-plane to Z-plane. So what is S-plane actually? That is your sigma plus j omega plane, right? Where you can mark your poles and zeros. How will you analyze stability in S-plane? Do you know this? Please respond.
Left side like
left side like so example you have to look at the pole location. See, you consider a transfer function like this. See, s plus 1 by s plus 2. Okay, what is the zeros over here? What is your zero? Zero implies then h of s, total h of s, the value of s. Zero implies the value of s for which the total transfer function will become 0. H of s will become 0. H of s 0 ആണെങ്കിൽ numerator has to be 0. Numerator 0 വന്നപ്പോഴാണ് s equal to -1. So this is the 0 of your transfer function. This particular example. Okay. Now, what is the pole? There is only one pole. Okay, let's see what is the pole. Pole implies the value of s for which your transfer function would become infinity. Transfer function has to become infinity. That means denominator has to become 0. That is the possibility. Denominator 0 ayale total function will be infinity. So denominator is 0 is applicable when s equal to -2. So this is referred as pole and this is referred as 0. This is how you will represent a pole and 0. This is 0 and this is pole. So I can mark, let me mark my pole in this particular transfer S plane. So this is s equal to -2. Okay, s equal to -2. S means sigma plus j omega, that is equal to -2, which implies your sigma is -2 and omega is 0. So the ordered pair -2, 0, that comes over here and this is your pole. Clear? So this is how you can mark. Let me mark the 0 also. Where is the 0? 0 is at -1. You will have 0 over here. So looking at the pole location, you can decide the stability of your system. So this is the condition for stability. Your poles should be in the left half plane. Okay. Poles in the left half plane implies if your location of pole is in the left half, you can say that your system is stable. What will happen to stability when if it is s -2? This -2 ആയിരുന്നെങ്കിൽ എന്ത് സംഭവിക്കും? Where will be your pole?
Right side.
Right side. Pole will be in the right side. So system will become unstable, right? So you can say that this system is stable because the poles are in the left half of the S plane. Clear, Ayala? So we have designed a stable system in the analog world. A stable system designed H of S designed and you are applying bilinear transformation to convert it to the Z plane. You should definitely ensure that the stability is not affected. System design transformation at the same time you should ensure that the stability of this system is not lost, or this transformation should not affect the stability. So to get that, to prove that, you should have a knowledge about stability in the Z plane. Z plane means R. Z is actually R e raised to j omega, right? So you will have circles of magnitude R. So ഇവിടെ boundary of left half is stable, right half is unstable, and you can say that in the imaginary axis it is marginally stable. So who is the boundary of stability? That is your imaginary axis. Sigma equal to 0 nu viliyam. That is the imaginary axis, right? So this is the boundary of stability and unstable sections in the S plane. Similarly, who will be the deciding factor or the boundary of the stability in this case?
Unit circle.
Unit circle, definitely unit circle. So this is the key factor. So this is R equal to 1 circle. Okay, you will represent mod z equal to 1 circle. Mod z is simply R, right? So that is R equal to 1 circle. That's R equal to 1 circle. So R equal to 1 circle, if you're in the Z plane, if the location of poles are within this unit circle, you can say that the system is stable. That means the value of R should be less than or equal to 1. This implies your system is stable. Your system is stable. So what we have to prove, now come back to the question, what you have to prove? You have to prove that all stable S-plane poles, that means a pole that comes over here, anywhere in the left half of the S-plane, all these people should be mapped to area inside the unit circle. That should come within the unit circle. Assume that you consider a specific person over here. Say I will use another color. See this particular pole, pink one, this particular pole. If he is mapped to a region outside the R equal to 1 circle, will this transformation be stable? You cannot use such a transformation because that is affecting your stability. So all stable poles should be mapped to the region that where that satisfies the condition of stability. So that should be mapped to region inside only. Pretty clear. So you have to prove that. So you cannot simply write any equation to transform from S to analog world. So what is the substitution that bilinear transformation is doing? You'll replace S with 2 by T, 1 minus Z raised to minus 1 by 1 plus Z raised to minus 1. You cannot simply formulate any equation. You cannot simply modify it as 2 minus Z raised to minus 1. Modify. You cannot propose anything like that. You can, but that should meet some important criteria. And one among that is stability. Okay, stability നമ്മളവിടെ ഒരു കാരണവശാലും affect ചെയ്യാൻ പാടില്ല. So this will not affect the stability, and the question is you have to prove that all the stable S-plane poles are mapped to stable Z-plane poles while using this substitution. That is the bilinear transformation. Okay, muting the mic for a minute. You just go through that one second. ഈ കാര്യം ക്ലിയർ ആണോ നോക്കുക. I will start the derivations. We'll move a bit fast. Okay, can I start?
E raised to j omega e raised to 0 ആയിട്ട് എങ്ങനെയാണ് സ്റ്റേബിൾ എന്ന് പറയുന്നത്?
കേട്ടില്ല. ഇവിടെയോ?
മോഡ് z equal to 1 ആണെങ്കിൽ
മോഡ് z എന്ന് വെച്ചാൽ എന്താ? മാഗ്നിറ്റ്യൂഡ് ഓഫ് ദിസ്. ഇതിന്റെ മാഗ്നിറ്റ്യൂഡ് എന്ന് വെച്ചാൽ 6 ആണ്. ഇത് ഫേസ് ആണ്. r equal to 1 അല്ലെങ്കിൽ അതിന്റെ അകത്തും ഇത് രണ്ടും വരും. ഞാൻ ഇതിനെ r equal to 1 എന്താണെന്ന് പറയാൻ വേണ്ടി ഇത് കാണിച്ചു. മോഡ് z equal to 1 എന്ന് നിങ്ങൾ കണ്ടിട്ടുണ്ടാവും, r equal to 1 എന്ന് കണ്ടിട്ടുണ്ടാവും. അത് രണ്ടും ഒന്ന് തന്നെയാണെന്ന് കാണിക്കാനാണ് ഇത് എഴുതിയത്. നത്തിങ് മോർ.
r equal to 1 is stable.
r equal to 1 is the margin of stability. സ്റ്റേബിൾ ആവണമെങ്കിൽ ഇതിന്റെ അകത്ത് വരണം. r less. This is the condition for stability in Z plane. r less than or equal to 1. Okay, r equal to 1 implies it's the verge of stability.
അതെന്താ സാർ അങ്ങനെ വന്നേ?
അത് സ്റ്റെബിലിറ്റി അനാലിസിസ് ആണ്. സ്റ്റേബിൾ സിസ്റ്റം എങ്ങനെ അനലൈസ് ചെയ്യാം എന്നുള്ള ഒരു മെത്തേഡാണ്.
യൂണിറ്റ് സർക്കിളിന്റെ ആക്സിസിൽ എന്തെല്ലാം ഉള്ളത്?
യൂണിറ്റ് സർക്കിളിന്റെ
ആക്സിസിൽ സാറിന്റെ ആക്സിസ് വരച്ചില്ലേ?
ഇത് ഇസഡ് പ്ലെയിൻ. ഇതിനെ ആക്സിസ് വരയ്ക്കാന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇതിനെ ഓവർലാപ്പ് ചെയ്ത് വരയ്ക്കാം. ഇവിടെ വരയ്ക്കാം. എസ് പ്ലെയിനുമായിട്ട് കമ്പയർ ചെയ്യാനാണ് നമ്മൾ ഇങ്ങനെ വരയ്ക്കുന്നത്. എസ് പ്ലെയിനായിട്ട് കമ്പയർ ചെയ്യുമ്പോൾ ഇത് സിഗ്മ പ്ലസ് ജെ ഒമേഗ എന്ന് തന്നെ വേണേൽ പറയാം. എസ് പ്ലെയിനിൽ ഓവർലാപ്പ് ചെയ്ത് ഈ സർക്കിൾ വരച്ചിരിക്കുകയാണ്. ഓക്കെ, ഇതിനെ ആക്ച്വലി ഇസഡ് പ്ലെയിൻ എന്നാണ് പറയുന്നത്. ദിസ് ഈസ് യുവർ ഇസഡ് പ്ലെയിൻ. ഓക്കെ, നൗ ഇപ്പൊ ഇവിടെ ഒരു പോയിന്റ് ആക്ച്വലി പറയുന്നത് ഇതാണ്. അതിനൊരു റേഡിയസും ഒരു ഫേസും ആണുള്ളത്. മനസ്സിലായോ? ഒരു റേഡിയസ് എന്ന് പറയുന്ന ആറും ഒരു ഫേസ് ഒമേഗയായിട്ട് ഒരു പോയിന്റ് വേണേൽ നമുക്ക് മാർക്ക് ചെയ്യാം. പക്ഷെ യൂഷ്വലി നമ്മൾ സർക്കിൾസ് ആയിട്ടായിരിക്കും കംപ്ലീറ്റ് പറയുക. നെക്സ്റ്റ് we will start deriving this. So we will start with this. This is a substitution that you are using. ശരിയാണല്ലോ? So I will start with this substitution. So this is a solution for the particular question asked. So substitution in bilinear transformation is S is 2 by T. വളരെ ഫാസ്റ്റ് ആയിട്ട് ഒന്ന് ഫോളോ ചെയ്ത് പോയിക്കോണം. Right? What was that? 1 minus z raised to minus 1 by 1 plus z raised to minus 1. Okay, this one. I'm going to rearrange it once. Then I am 2 by T into this is 1 minus 1 by z by 1 plus 1 by z, right? So if you cross multiply this, you will have 2 by T into z minus 1 divided by z varum. Denominator z plus 1 divided by z varum. So this will get cancelled and this is what you will get. 2 by T into z minus 1 by z plus 1. ശരിയല്ലേ? Then ഒന്ന് rearrange ചെയ്യുന്നു. Okay. So 2 by T into z minus 1 by z plus 1. Either you can work it out right now or support me in doing. Okay, ഏത് രീതിയിൽ വേണം ചെയ്യാം. രണ്ട് പാരലൽ ആയിട്ട് പറ്റുമെങ്കിൽ ചെയ്യാം. സ്പീഡ് കുറവുള്ളവർ ജസ്റ്റ് എന്നെ സപ്പോർട്ട് ചെയ്താൽ മതി. പിന്നെ വീഡിയോ കണ്ടിട്ട് ബുക്കിലേക്ക് തന്നെ ട്രൈ ചെയ്താലും മതി. So this is a substitution that you are using. So actually S implies sigma plus j omega. അതാണ് S എന്ന് പറയുന്നത്. Okay, and what is Z actually? Z is your R e raised to j omega. And S was your sigma plus j omega. I'm going to make a comparison between these two people. What happens with my sigma omega and all those things. So this is 2 by T into, you can write here R e raised to j omega minus 1 divided by R e raised to j omega plus 1. Fine. Now, ഇവിടെ modify ചെയ്യാൻ പോവാണ്. 2 by T into R e raised to j omega. E raised to j omega can be expanded. E raised to j omega എന്ന് പറയുന്നത് cos omega plus j sin omega ആണ്. Okay. Okay. E raised to j omega can be replaced with what? Cos omega plus j sin omega. Minus 1 divided by next R into cos omega plus j sin omega plus 1. Okay, now you can open this bracket. R1 to bracket open GM. So this will be 2 by T. I'm keeping LHS as such. LHS, you have to compare the LHS and RHS. So what my ultimate object is, I have to split this term as a real term plus j imaginary term. Real imaginary I have to completely split from this complex expression, so that I can compare what is sigma and what is omega. Okay, so there is one big mistake we have done over here with this thing. ഇവിടെ എന്തെങ്കിലും പ്രശ്നമുണ്ടോ? This should be capital omega. I mute അല്ലല്ലോ. അല്ല, okay. This should be capital omega. Why? You are in analog world. Okay, you are in analog world. നേരത്തെ plane വരച്ചപ്പോഴും that should be capital omega, right? So 2 by T into, just open the brackets, you will have R cos omega minus 1 I can write, that is the real part, plus j r sine omega. That is the imaginary part of the numerator. Similarly, with the denominator also, you can write r cos omega plus 1 plus j r sine omega. Is that okay? Respond, okay?
Yes, yes.
Okay. Now you can multiply and divide with this conjugate of the denominator. This is the denominator, a plus jb. Okay. So multiply and divide with the conjugate. So conjugate is r cos omega plus 1 plus j. Instead of plus j, I will use minus j. Minus j r sine omega. Here also again same time r cos omega plus 1 minus j r sine omega. So let's see the denominator first. Denominator is actually a plus ib into a minus ib, right? So that is a square minus b square. So a is this thing. So a square is r cos omega plus 1 square. This is a square minus b square. B is this thing. Square of that. J square will become minus 1. Minus of minus will become plus. Then r sine omega square. So that is r square sine square omega. So that is the denominator. Focus. I will simply do it in a single step. Or single step. Are you ready? Numerator ne single step. This thing into this thing. A plus IB into C plus, okay, or C minus ID. So let me multiply this into this first. Idhine idhu multiply. So what you will get? This term into this term. Again, this is of the form A minus IB into, sorry. This is A minus B into A plus B, right? A minus B into A plus B. So just square A square minus B square. So you will have R square cos square omega minus 1 square. So that is 1. Clear? This is multiply. Right? Now you have to multiply this with this. That will be an imaginary term because of this j. Then you have to multiply this with this. That will be again an imaginary term because of j. You will have one more real part. So this thing into this thing. That will be a real term. So j plus into minus, you will have minus, right? This term minus. J into j square, that will become plus. Then you have r sine omega into r sine omega. So this will be r square sine square omega. This is the real part of the numerator. This is the real part of the total numerator. Plus or minus, whatever it is, you will have an imaginary part. Let's find it. Imaginary part again, this term into this minus j, right? Then this into this. Then open j, you will have minus j r square sine omega cos omega, right? You will have r square sine omega cos square. Sine is minus. Then when you open this bracket, you will have again r square sine omega cos omega. There the sign is plus. So our terms cancel out. The only term left is this thing into step. Follow simple math. Bracket open step. You do it yourself. Okay. So minus 1. Where was this? Minus 1 into this. So this minus into minus will become plus. Plus jr sine omega is one term. Then again plus 1 into this thing. Plus jr sine omega is the other term. So you will have 2 jr sine omega. So you will get it as j into 2r sine omega. Let me verify this. Yeah, it's 2r sine omega. Clear avatar? Just open the brackets, you will get it. Nothing more. So the numerator can be further simplified 2 by t into, see, if you open this bracket, no need of bracket because this is simply plus, right? So this is r square cos square omega time, r square sin square omega time. From both these terms, if you take r square common outside, what you will get? Sin square omega plus cos square omega, that is 1. So that will simply become r square. Then what left is r square minus 1. So this is actually the real part of the numerator. And the imaginary part is 2r sine omega. All divided by, let's simplify the denominator also. When you open this bracket, what you will get? R square cos square omega plus 2 into r cos omega. Then it is r square cos square omega plus 2r cos omega plus 1. Plus you have another term also there, right? R square sin square omega. So here again, if you take this r square common outside, you will have cos square omega plus sin square omega. That is again 1. And the final answer will be, let me write in another page. So the final expression for you, that will be from this, that will be 2 by t, numerator is r square minus 1 plus j 2r sin omega, right? All divided by, you will have r square plus 2r cos omega plus 1. This is the denominator. So this is the final expression that we got. What was the LHS? Sigma plus j omega. Okay, so we will wind up in few minutes. Just look at this. What is sigma from this? Tell me the value of sigma. What is
2
sigma?
by t r
2 by
square
t
minus 1.
r square minus 1 divided by r square plus 2r cos omega plus 1, right? And similarly, what is omega? 2 by t into 2r sin omega divided by r square plus 2r cos omega plus 1. So these are the expressions. See, this thing, from this thing you can derive omega is equal to 2 by t tan omega by 2. നമുക്കത് പറ്റിയാൽ അടുത്ത ദിവസം ചെയ്യാം. Okay, നമ്മൾ അത്രയും പോകുന്നില്ല. We'll do it in the next class. Now our concern is only with the sigma. So this is the relation between, or this is how you can find sigma. Sigma and r is related like this. So my question is, what was the thing you have to prove? All S-plane poles, all stable S-plane poles, right? You have to prove that all stable S-plane poles are mapped to, all stable S-plane poles are mapped to stable Z-plane poles. So we will start with this axis. Let's see what happens with this axis, where it is mapped. This axis is mapped. So how can you address this axis?
J omega equal to 0.
J omega 0, sigma equal to 0. Isn't it? That axis is sigma equal to 0. So let me take first case 1. Let me take sigma equal to 0. So that is your imaginary axis, j omega axis in the S plane. So let me see what happens with that. Ready or not? Sigma equal to 0 implies this numerator has to be 0, isn't it? Sigma 0, this numerator will be 0. That means r square minus 1 equal to 0, which implies that r equal to plus or minus 1.
Sir.
Okay. So what you understood from this? That's the question. What you understood from this? Sigma equal to 0 in the S plane is transformed to r equal to 1. So if you draw to axis, this is the S plane, this is the S plane, and this is the Z plane. So what can you say? The imaginary axis, sigma equal to 0, that is mapped to where? R equal to 1. What is R equal to 1? Unit circle, R equal to 1. So this is the first case. So we proved that the imaginary axis is transformed to R equal to 1. So my question is, what about the poles in this? But all the poles are not transfer. That is to the unit circle. That will be transferred to the unit circle. All poles in the j omega axis, sigma equal to 0 axis, will be transformed over here. What about their stability? Stability nashtapato? Or is it? Illa. Stability nashtapattilla. You are perfectly stable. You were in the verge of stability over here. Here also you are in the verge of stability. Clear? Instead, if you got r equal to 2 over here, you found some other transformation and say that your r equal to 2 for the sigma equal to 0 case. what is your conclusion from that? R equal to 2 implies that will fall outside this unit circle. That means they were stable over here or marginally stable over here, but when you transformed, they went to unstable locations. So അങ്ങനെ transformation നമുക്ക് acceptable അല്ല. But fortunately, bilinear transformation is not like that. The stable S-plane poles are mapped to stable Z-plane poles. So we have analyzed only this case. We have analyzed only the marginally stable condition. What is the other stable poles? Where can be the other stable poles in the S-plane? Second case, case 2. Any poles stable in S-plane?
Less than 0.
Sigma less than 0. Now let's try that condition, which implies for the above equation, when sigma is less than 0 means r square minus 1 is negative, right? R square minus 1 is less than 0. Okay, so which implies that r square is less than 1. Therefore, you can say that r is less than 1. So what happened with sigma equal to 0, less than 0 cases? Sigma less than 0 means where it falls. This is actually case 1. For case 2, I will try to use another color. Let me see. Okay, so this was case 1, sorry, case 2, sigma less than 0. So the poles over here, this is sigma less than 0, sigma less than 0. All these poles will be mapped to where r less than 1. So when they are mapped, they comes in the unit circle, within the unit circle. This is r equal to 1 was exactly the unit circle, and r less than 1 is inside unit circle. So here also they are safe because they are in the region of stability. So we can conclude that all the stable S-plane poles, we have analyzed all the stable S-plane poles. So we can prove that all stable S-plane poles are mapped to stable Z-plane poles. Clear, Aya? So that's it. Confusion allora others can leave.